In today's video, I'm going to be discussing the mechanism of pathogenesis by Mycobacterium tuberculosis. This bacterium serves as a pathogen in tuberculosis or TB infection. Mycobacterium tuberculosis is a rod-shaped bacterium that is found in airborne particles, otherwise known as droplet nuclei, which span approximately 1 to 5 microns in diameter. Its unique cell wall full of lipids serves as a key virulence factor. Transmission of tuberculosis is through air, not by surface contact, and occurs when an individual inhales the droplet nuclei containing Mycobacterium tuberculosis, which is normally through coughing, sneezing, and talking of others infected. Tuberculosis infection occurs in 4 stages: the initial macrophage response, the growth stage, the immune control stage, and the recovery stage. During the first stage, after the droplet nuclei are inhaled, bacilli enter the lungs, traveling to the terminal bronchiole to the alveoli. Infection happens when droplet nuclei reach the alveoli and begin to multiply. During the initial macrophage response, this foreign bacteria will be attacked by macrophages, which is a type of immune cell. However, if the macrophage is not strong enough to attack, resistance occurs, which leads to the next phase and progression of TB. During the second stage, the growth stage, bacteria grow exponentially. A small amount enters the bloodstream where it has the ability to spread to other parts of the body. It is more likely to manifest in susceptible areas, such as the brain, larynx, lymph nodes, kidneys, and most common, lungs. This exponential growth phase is where symptoms normally show. Approximately 2 to 8 weeks after the initial infection, a stronger systemic immune response occurs. This is the immune control stage, in which the bacteria do not grow exponentially anymore, and their growth rate is balanced by the macrophage and other immune cells. The cells can form a granuloma or a barrier shell, which keeps the bacilli contained by the macrophage. During the final stage, the body begins to recover and scar tissue may be found on X-rays. One specific lesion called the gone focus is significant to pulmonary infection of TB. Tuberculosis can become reactivated 12 to 24 months after initial infection. This normally occurs in a weakened immune system. It is possible to have a small amount of TB bacteria in the body and it to be inactive. This is called latent tuberculosis infection, or LTBI. Individuals with LTBI cannot spread the TB bacteria to others. LTBI occurs after the extracellular bacteria are initially engulfed by macrophages, presented to the white blood cells, and the granuloma are able to keep them contained. LTBI transitions to TB disease if not treated. Those who have TB experience cough and fever as their main symptoms and can be diagnosed by a TB skin test or blood test, a chest radiograph, and culture. Active infection is normally treated with a variety of antibacterial medications for 6 to 12 months. There are several factors which determine the probability of transmission, which are susceptibility, the immune status of the exposed individual, infectiousness, which is determined by the number of TB bacteria that he or she expels into the air, environmental factors, and exposure, such as proximity, frequency, and duration.